Hi, my name is C. Ikshita and I am from ECU branch. My roll number is 23 4G 1A0429. Today I am going to present a PPT about the topic Derived Bandwidth of an RLC series circuit. Subject name Network Analysis. Subject code 23 203. Moving to the next page. Introduction to RLC series circuits. RLC series circuits are electrical circuits that contain a resistor R, an inductor L and capacitor C connected in series. These components work together to create complex electrical behavior, making RLC circuits useful for a variety of applications. So here is a diagram for introduction to RLC series circuits. Defining bandwidth in RLC circuits. Frequency response, transfer function, quality factor. The bandwidth of an RLC series circuit is the range frequencies over which the circuit's output amplitude remains within a specified percentage of its maximum value, typically 3 dB or 70.7%. The bandwidth is directly related to the circuit's transfer function, which describes how the output signal is affected by the input signal across a range of frequencies. The bandwidth is inversely proportional to the circuit's quality factor, which measures the selectivity or sharpness of the circuit's frequency response. Relationship between resistance, inductance, and capacitance. In an RLC series circuit, the resistance R, inductance L, and capacitance C work together to determine overall behavior of the circuit. The interplay between these three components is crucial in defining the bandwidth of a system. The resistance affects the overall current flow. The inductance influences the circuit's ability to store and release energy, and the capacitance determines the circuit's capacity to store and release electrical charge. The combination of these elements dictates the frequency response of the bandwidth and RLC circuit. Derivation of bandwidth formula. Step 1. The bandwidth of an RLC circuit is determined by the relationship between the resistance R, inductance L, and capacitance C of the circuit. Step 2. The resonance frequency of the RLC circuit is calculated as 1 by 2 pi root of LC. Step 3. The bandwidth is defined as the frequency range between the 2 points where the power is half the maximum value or minus 3 dB points. Factors affecting bandwidth in RLC circuits. Resistance, inductance, capacitance, frequency. Higher resistance in the circuit reduces the overall bandwidth as it damps in the circuit ability to respond to rapid changes in the input signal. Inductance. Increased inductance leads to a narrow bandwidth as the inductor's reactance limits the high frequency response of the circuit. Larger capacitance values result in a wider bandwidth as the capacitor's reactance allows for better right frequency signal transmission. The operating frequency of the circuit also affects the bandwidth, with higher frequencies generally allowing for wider bandwidths. Importance of bandwidth in circuit design. Bandwidth is a crucial parameter in circuit design as it determines the range of frequencies that can be effectively transmitted or proceeded by the circuit. Proper bandwidth management is essential for ensuring optimal performance and preventing signal distortion or loss. Practical applications of bandwidth in electronics. Radio communications, audio applications, digital data transmission. Bandwidth is critical for transmitting high quality audio and video signals in radio, TV and wireless communication systems. Sufficient bandwidth is required for high sound reproduction in musical players, speakers and audio amplifiers. Limitations and considerations in bandwidth calculation. Influence of component tolerances, nonlinear components, frequency dependence. Comparison of bandwidth in different circuit configurations. 20 kHz, 10 kHz, 5 kHz. Bandwidth of RLC circuits with low resistance, bandwidth of RLC circuits with moderate, bandwidth of RLC circuit with high resistance. Conclusion and key takeaways. Bandwidth importance. The bandwidth of RLC series circuit is critical parameter that determines the frequency range over which the circuit can effectively operate. It is essential for proper circuit design and performance. Factors to consider: resistance, inductance, and capacitance values all impact the bandwidth of the circuit. Understanding their relationship is to key optimizing the circuit's frequency response. Practical applications. Bandwidth considerations are crucial in various electronic applications, including communication systems, audio equipment, and filter design, ensuring efficient signal transmission and processing. Thank you.